Let me show you that this is working also with other programs, because now it's behaving like a general packer. So let me show you. I'm gonna go and open the 32-bit version of Notepad. You can find it in C, Windows, sys 64. I'm just gonna search for Notepad. I think it's here somewhere. Yeah, this one. Copy, paste it here. I'm just gonna copy it here. We can right click on Notepad. We see that's a 32 portable executable. In section headers there's nothing, there are few sections here. Also it's a valid PE file. So now we're gonna add a new section inside this Notepad. So right click here. Okay, so ethical injector.exe. The section name is gonna call hack. The target is gonna be Notepad, because we want to enter um, a file inside the Notepad. Okay, so notepad.exe, and the file we want to add there, let's just find another image. So not this one, this with flowers. I'm gonna save it here. So tulips. Okay, so the same path. I'm just gonna call it tulips.jpg. Okay, so we're gonna hit enter. Notice that Notepad size will increase. So it successfully increased. Okay, so right now I'm gonna delete these two files from here. So if I right click in Notepad with CFF Explorer, we're gonna see that in section header there is a section called hack, and with I click it there is an image file. Okay, and if I want to, so right now, yeah, let's dump it to make sure that it's a valid image. So on this section we click dump section. It's gonna hack.jpg on the desktop, and yes, it's just outputted the image. So now imagine this is our loader. We send it to someone, and when it double clicks on it, it actually dump out the file from this section, and it's gonna call run DLL32 to proceed further. Hi guys, and welcome back to my channel. We will continue with part 2 of the ethical red. We will write the actual injector, which will create a new section inside the valid PE file, and it will also write code to it. So this injector will be something like a general packer for PE files, because we will write it to work with any PE file. So as an example, we can make later a loader and inject inside our DLL, but I also want to be able to create a new section inside notepad.exe and add our DLL inside. So it will work with both of them. So before we start, let me show you. I'm gonna open the DLL, fun DLL. So fun DLL, as you can see, as I told you, there are those headers, anti-headers. Inside the anti-headers there are file header and optional header. Inside optional header there are data directories and section headers at the end. Okay, if we don't look at the structure of this and we look at in a hex editor, we can see that our DLL looks a bit funny, because here is the actual code of it. Yeah, it starts with MZ, so this shows that it's a valid image DOS header, so it's a valid PE file. Okay, this is actually 5A4D, because in assembly it's being read from right to left. And you can see here is actually the DLL code, so it's structured. Okay, we cannot find here an actual order, so we can write a section to create a new section and then write code to it. So that's why we need somehow to iterate between these things here, and when we reach the section headers, when we are here to actually add the new section and then the right virtual size, at the right virtual address with row size 2 and so on. Okay, so in order to do that we need some kind of alignment. So we need to align section header based on section size, alignment and address, so we can actually write our code here in this part of the program. So we're gonna start like this. So since this is a console app, we're gonna use it like this in CMD. So the name of it, ethical injector.exe. Then I assume we should enter the section name, what we want to create, then the target process, um, where we want our DLL to be injected, and then our DLL. Okay, so we're gonna call it in CMD like this. Okay, so let's start. So this would be argv0, argv1, argv2 and argv3. Okay, we need to make sure that all of them are not empty. So if argv0, then argv1, 2 and 3, okay, then we can start. I'm gonna define it like this. It will be a char pointer. This will be the loader path. Loader path, it will be this target. Okay, well, I'm gonna define it like loader. Or you know what? We're gonna define it as target process. Okay, this will be argv2, then our DLL, so this will be the DLL path. This is the last one, so this is argv3, and the section name will be a pchar section name. This will be argv1. Okay, now we need to create a file handle. So we're gonna use create file A. So this will be a handle. I don't know, let's just call it X file. This is going to be create file A, and here we need to specify. So we're gonna create a file handle based on the target process. We need a generic a read flag and also generic write. Okay, share mode can be 0, null. We can open existing if there is already, and the file attributes gonna be just normal, so we don't care too much about this. Okay, and I guess there is the template. I'm gonna just put 0. Let me just put this here. Alright, so if this X file is not equal with invalid handle value, so one second, needs to delete this. So if there's actually a valid handle created from this file, then we're gonna do the following. We need to store first the file size, so we're gonna store it in a 4-byte type variable, so that's a D word. I'm just gonna say file size. This is gonna be equal with get file size of this X file, and the LP file size high, we don't care right now, so it's gonna be null. We're gonna write a p byte because we need to allocate, we need to create a buffer for this file, so it's gonna be file buffer. This is gonna be p byte local alloc lptr file size it's file size. Yeah, so we need the lmem and l init, l0 init here. And then we also need another D word where we're gonna store the return bytes for this file, because we're gonna read it later. So the return bytes. Okay, now let's read the file. So we're gonna store it inside a bool variable. So we're just gonna, I don't know, we're gonna name this file read equal read file. Hold on. This X file inside this, so we're gonna store it inside file buffer, this file size, and we're gonna store everything inside this return bytes. So we're gonna difference this return bytes. Okay, and the overlap, we don't care, it's just gonna be null. Okay, and now we check if this file read is equal with true, if it returned true, and also if this return byte is equals with file size. So if this function has actually been able to read this X file and return all of its bytes inside this return bytes variable. So if this is true with the actual file size, then we can proceed. So now let me just open again fun.dll. So first we need to make sure that where we want to inject the file, so we are talking right here about the loader, it is a valid PE file. You see, portable executable 32, so it's a valid one. To do that, we can see that in hex editor, every P file starts with 4D5A, yes, which is in assembly actually 5A4D. Okay, this is the MZ. So if the file starts with MZ, that means that it's a valid PE file. So to do that, we're gonna create a variable type pimage.header. Okay, I'm just gonna write it image.header. I'm just gonna name it. I'm gonna typecast this to pimage.header of this actual file read. Okay, so now we need to check if that signature is valid. So we're gonna do if this, we're gonna get out the imagic. I'm gonna tell you in 1 second. If it's equal with image.signature, then it means it's a valid PE file. Okay, that means that this is the magic number. So if we go back here in DOS header, we can see that there is like a table where stores the most important members, and we see that imagic has the 5A4D. We have seen that inside the loader is actually 4D5A, but in assembly you read it and write it from right to left. So we need to make sure that where is it? Here. If eMagic it's exactly 5A4D. If that's the case, then that means the file is actually valid. It's a PE file. So we need to check against image.signature. If we hover over, you can see that it expands to 0x5A4D. So it checks if it's 0x5A4D. Yeah. So if it's valid, if PE valid, then we're gonna do the following. We need to get the image file header, the image optional header, and also the image section header. Okay, so we need to get the image file header, yeah, image optional header, and also the image section header. Okay, to do that we're gonna do the following: p image file header, image file header, typecast always, and here we're gonna do something like this. It's gonna be the file read plus image dos header. We're gonna get out that ELFA new, and plus also the size of a D word. Okay, so it's gonna look like this: file read plus image dos header LFA new, ELFA new, with this plus this. Okay, then we get the image optional header, so p image optional header, which is image optional header. Again, we gonna typecast to this, and it's gonna be exactly like above, but we're gonna add the size of the image file header. Okay, this is what we add, so it's gonna look like this, the optional header. Then we also want the p image section header. Okay, so image section header, again you're gonna typecast it, this will be a bit different. It is exactly like above until here, until LFA new, so it's file read plus image.header LFA new plus the size of the actual image NT headers, NT headers. Okay, so this is how we access the section header, and I like to store it in a 2 byte the PE sections. So that would be image file section, image file header. We're gonna get out the number of sections and we're gonna store it inside this variable. Okay, now we need to use zero memory and copy memory, so we can zero out the memory inside the section, and also we're gonna copy the size of the section name here. So we're gonna do like this: zero memory something, and then copy memory and something. Okay, so in zero memory we need to do as follows. So image section header, we're gonna get these PE sections, so all of them, and it will be as size of image section header. Okay, so like this without the P. Yeah, so it's image section header. You notice it's highlighting it because it says it's not suitable for this conversion, because we need to actually differentiate. Okay, and then we're gonna do the same thing here with copy memory, but we need to access the name of the section, and here we're gonna enter the section name what we created above, and the length must be at least maximum 8. So if you notice here in the section headers, it has just 8 bytes maximum. It doesn't let you to enter more than 8 bytes. Okay, alright, once this is done we will read the DLL file. So handle code file create file A. I think I named it DLL path. Yeah. Generic read, because we just read it, we don't write anything to it. 0 null open existing. Then the file attribute, it's still normal, and also here is null, like above. So once this code file, so the file that actually has code and we want this code to inject it into the loader, that's why I name it code file. If it's not invalid handler, same like before, invalid handler value, then we can proceed. Okay, so we're gonna get the file size here as well. So dword DLL size is gonna be get file size of this code file, and here is 0. I cannot type. And then if this DLL size is greater than 0, so if we have successfully retrieved the size, then we're gonna allocate another buffer. So pbyte DLL buffer equals with pbyte local alloc lptr lmem and l0 init, and then the code size, DLL size. Okay, and if this DLL buffer is not error, so it's not equal with error, we're gonna do the following. We're gonna store first inside a dword the returned DLL bytes, like this. So first we check again if this handle, okay, but before that we gonna read here the file and put the buffer inside the DLL buffer. So bool DLL read equals read file, and then the DLL this will be the code file, and then the DLL buffer, inside the DLL buffer DLL size, then we difference to the return DLL bytes, and here will be null for overlap, we don't care about that. Okay, now if this DLL read is true, no errors, and also like above, if this return bytes, DLL return bytes equals exactly with the DLL size, so we read successfully the DLL, we will actually enter, we will actually create the section and inside the PE. First, we need to set a file pointer inside the PE section, inside the section header. So if set file pointer something, it's not equal with invalid set file pointer, then we gonna proceed. So here we're gonna have the following. Here is the actual X file, then image section header, PE sections, pointer to raw data, yeah, and then plus the same, except we need the size of raw data, size of raw data, okay. Don't forget to add the distance to null and file begin. Okay, so it looks something like this. So set file pointer, X file, image section header, the P sections, pointer to raw data, plus the size of raw data, then null file begin, and if all of this is not invalid, then we can continue. So we're gonna do the following. As I said, here we need to actually, you see, when I add here, 1 second, a section with empty space too, it doesn't matter. You see, it adds, you notice it adds a specific virtual size, also row address, and so on. Okay, so we need somehow to align all of this. And also we need to make sure that we enter here the right characteristics. So we can see, for example, the text section. If we right click here and change section flags, we can see what characteristics it has. Just notice these things because we're gonna use them later. It's executable, readable, contains code, and so on. Okay, so first we need to use some kind of alignment, as I said before, to be able to add a section. For this, I'm gonna create here a function, and it's gonna be a type of D word. I'm just gonna call it align section header. Okay, and this has 3 parameters. All of them are 4 bytes, so it's gonna have the section size. Then we need also the alignment and also the address. Yeah, so we have it like this. And if it's so if section size module alignment, it's true, but we need it actually not to be true, so we're gonna put it in double brackets and here exclamation mark. So if it's not, then we just gonna return the address plus the section size. Else we're gonna return, so pay attention here, address plus something times the alignment. Okay, so this something will be the section size divided by alignment plus 1. Okay, I'm not gonna get too much into it. I'm gonna put a link down below so you can understand why we need this formula to align the section header. Okay, so once we have this function written here, we go back and we continue to add the section with the proper alignment in the right way. So first, as I said, we use we use this. You just copy the image section header PE sections, yeah, because we're gonna use it a lot. So first we need the virtual size to align it. So the virtual size, you can find it in MISC, that virtual size. This is gonna be equal with something. I'm just gonna put an X. Then we need to align the virtual address. Then we need to align the size of raw data. Then we need a pointer to raw data. Pointer to raw data. And then the characteristics. Okay, what I showed you before. Okay, let's see how we can populate all of this: virtual size, virtual address, size of raw data, pointer to raw data, and characteristics. Okay, so the virtual size, we're gonna call here the function, so align section header. Yeah, we just gonna copy paste now this, because this is what we're gonna do. So we're gonna align the section header in all of these except characteristics here. Not I'm gonna tell you later. So the virtual size is, it's gonna be the DLL size, and then from image optional header we're gonna get out the section alignment, and here the address is 0. Okay, so it's gonna look like this. Now the virtual address, MISC virtual size. Okay, and then here we have the same image optional, no, this one, section alignment. Then the address will be image section header PE section -1. If anyone knows why it's -1, just write it in the description. I'm curious if anyone knows why. So here will be virtual address. Sorry, image virtual address. Okay, so the virtual address looks like this. Now size of raw data. The size of raw data, it's simple. It's just the DLL size, and then image optional header file alignment. So here is the file alignment. Okay, file alignment, yeah, not the section alignment, the file alignment. Address is 0. Okay, and we have the pointer to raw data. So here we're gonna do the same thing almost like the virtual address. So it's gonna have the image section header, the P sections -1. We're gonna retrieve the last one. Then size of raw data. Then we have image optional header, file alignment, and then we have also the address, which will be image section header -1, so the last one, dot pointer to raw data. Okay, so it's gonna look like this. Okay, and now the characteristics, we just gonna use the exact ones that we require. So everything capitalized. It's gonna be the image scn memwrite, then also the image scn cnt, then code. We write code to it too. Sorry, just let me. Okay, then we need the image, what is that called, image scn cnt something with uninitialized data, that's right. Then we need image scn mem execute, because we also execute code here. Then image scn cnt initialize data, and also image scn mem read. Yeah, you can read about these characteristics on MSDN. So once we aligned everything correctly, hopefully I did it correctly, we're gonna check it. We're gonna set the file pointer, and then we're gonna set the end of the file. So we're gonna set a file pointer right now inside this X file, which is the loader. And if it's returning okay, then we're gonna set the end of the file to this X file. So we're gonna do something like, if set file pointer it's not equal with invalid set file pointer, then I'm gonna tell you what we're gonna write here. Then we're gonna set the end of the file to this X file. Okay, all right. So here we're gonna write the following. So it's gonna be X file, then image section header PE sections, pointer to raw data. Let me just move it right, plus image section header PE sections. Here is the size of raw data, then just null, and the move method is gonna be file begin. Okay, so if it's not invalid set file pointer, we're just gonna set the end of the file to this X file. Okay, after we finished with this, we just need to resize the size of the image. So image optional header, size of image is gonna be the image section header PE sections virtual address plus I'm just gonna copy this, plus misc, sorry, so it's image misc virtual size. So we need the virtual address plus the virtual size, and that's it. And we just need to remember that we have added a new section, and we need to increment that. So it's gonna be image file header, there are the sections, number of sections plus 1. Okay, alright, so we have finished that. Now we need to add the actual code to the section, and then we're gonna write the whole file back to X file. Okay, so if we're gonna set again file pointer, set file, hold on, set file pointer X file 0 this time, null, and file begin. If it's not equal with invalid set file pointer, okay, then we're gonna add here the section. So to do that, we're just gonna write file to this X file. Here we're gonna write the file read, to which file we have read. then it is the return bytes, no, the actual file size. And here are the, we're gonna differentiate to return bytes. Okay, the overlap, it's null. Okay, so we're gonna add the section. Just let me close all the handles correctly. So here, this is the DLL read. So here we're gonna local free then here we're gonna close the code file. So close handle code file. Then I believe here we're gonna local free the file buffer. So local free file buffer, and then here this is the X file. Okay, so after that we just, not here, we're gonna do it here, we just gonna close the handle of that X file. Okay, so let me see what's gonna happen. So we go to the project, right click, rebuild. Hopefully we don't get any errors. Okay, now I'm just gonna close this DLL. No, I'm gonna, okay, it is here. So we're gonna go to open ethical injector. Is inside debug. So here is the injector, this is the DLL. Just let me think how we're gonna do this. So so I'm gonna go and get a picture. I'm gonna get the picture with the penguins and I'm gonna put it here. So I'm gonna use this program to inject this file inside our DLL. Okay, we're gonna do it like this. So I'm gonna open here a command prompt, so shift and right click, open command window here. And if you remember, let me go back up, these are our commands, so we're gonna use the arguments like this. So first is ethical injector.exe, then we need a section name. I'm just gonna put dot hello. Then the target will be DLL because we're gonna put this file inside the DLL. So we're gonna copy the path. I'm gonna put here quotation marks, paste it, slash fun dll.dll. This is the target, and the actual file that we want to put inside, it's this one, it's penguins.jpg. So I'm gonna put here space, then other quotations, backslash penguins.jpg. So if this succeeds, then you're gonna realize that FunDLL is gonna increase its size. So now FunDLL has 70 kilobytes, yeah? So we're gonna hit enter and it stopped working. So we received an error because on line 3 actually it's not file read, it's file buffer. We actually need to typecast the pimage header to the file buffer because we read it and it's gonna be allocated here. And also make sure here is also file buffer, all these three. Okay, so once that's finished, just go on Solution Explorer and rebuild the program. Okay, now we're going to open it. We're just gonna leave it like in debug mode right now. Debug. Okay, so we open here a command prompt, and we're gonna use the arguments as described here. So first is the actual program name, so ethical injector.exe. Then the section name, I'm just gonna call it .hello, I don't know. Then the target is gonna be the DLL, because we want to inject this image inside the DLL. So the target now is the DLL, so I'm gonna copy the path of the DLL here. Okay, and then space, and now we need the actual file that we want to inject with. So that will be the penguins. Okay, so quotation marks penguins.jpg. Okay, penguins. But before I hit enter, I'm gonna show you that if we right click on CFF Explorer and we go to section headers, there is no other sections here added. This is just the default sections. But when I hit enter, just notice how the size will increase. So did you see? It's now 830 kilobytes. And when we can close this now, when we access the fun DLL32 DLL with CFF Explorer, and we notice the P file size and P size has been increased, and in section headers we can see here a section called hello, but there is no actual code here, so we just created a section right now. Okay, we actually successfully put here the section, yeah. And if we right click here and change section flags, we can see that all these characteristics that we have entered here, they've been successfully validated and recognized here. So now that we created the section here successfully, let's add the image. So to do that, we have added a section. Once we have set the file pointer here and added the section, we get out of this if statement, and here we actually gonna add the file like above, but we just gonna change something. So it's gonna be DLL buffer, and then here is gonna be DLL size. If I remember correctly, this is how we name them. And here instead of return bytes, I think, yeah, I'm gonna declare here unused bytes with lower b and lower u, and then we're gonna write here unused bytes. Okay, so this is how we add the section, and this is how we add the file, and then we close and free the buffers like this. So let's check if this is working. I'm gonna go again and rebuild the project, and then I'm gonna go and open it. I think I have it here. Let me open it again. Okay, so now again we want to add the penguins inside the DLL. So we're gonna open here the command prompt again. We're gonna call it like this: ethical injector.exe hello. Here is gonna be the target. So the target is gonna be DLL, because inside the DLL we want to enter something. So fun DLL.dll, and then here is gonna be our file that we want to inject with. So paste, and then penguins.jpg. Okay, so notice again. um, okay, hold on. Right now the DLL has already inside a section, so that's not okay. So we're gonna go here and right click and rebuild. Okay, once it's rebuilt, you can see that DLL now has 70 kilobytes again. So we're gonna make sure that there is no section inside. No section. Okay, we're gonna add the section. Now DLL has increased its size. We're gonna right click the CFF Explorer. We see that it's increased successfully. We go to section headers. We're gonna see now that there is the hello, and we also see here that the file has been successfully added, the penguins file. Okay, so just to make sure that that's the same image file, we're gonna open this with PE Explorer again. We're gonna go here and dump this section on the desktop. I'm just gonna write this hello.jpg, and as you can see, I successfully outputted the file from inside the program. Let me show you that this is working also with other programs, because now it's behaving like a general packer. So let me show you. I'm gonna go and open the 32-bit version of Notepad. You can find it in C, Windows, sys 64. I'm just gonna search for Notepad. I think it's here somewhere. Yeah, this one. Copy, paste it here. I'm just gonna copy it here. We can right click on Notepad. We see that's a 32 portable executable. In section headers there's nothing, there are few sections here. Also it's a valid PE file. So now we're gonna add a new section inside this Notepad. So right click here. Okay, so particle injector.exe. The section name is gonna call hack. The target is gonna be Notepad, because we want to enter um, a file inside the Notepad. Okay, so notepad.exe, and the file we want to add there, let's just find another image. So not this one, this with flowers. I'm gonna save it here. So tulips. Okay, so the same path. I'm just gonna call it tulips.jpg. Okay, so we're gonna hit enter. Notice that Notepad size will increase. So it successfully increased. Okay, so right now I'm gonna delete these two files from here. So if I right click in Notepad with CFF Explorer, we're gonna see that in section header there is a section called hack, and with I click it, there is an image file. Okay, and if I want to, so right now, yeah, let's dump it to make sure that it's a valid image. So on this section we click dump section. It's gonna hack.jpg on the desktop, and yes, it's just outputted the image. So now imagine this is our loader. We send it to someone, and when it double clicks on it, it actually dump out the file from this section, and it's gonna call run DLL32 to proceed further. I know it took so long to be here, but I don't code so slow. The thing is that I want you to understand how some of the things are working. Okay, stay tuned for the next tutorial. If you like this video, please give a thumbs up and also subscribe, and thanks for watching. Bye.